Welcome back to the drive-thru, sponsored by the deli. Hungry? Stop by the deli and get yourself a lottery ticket. It's the hot topic today at the deli. Trying to convince a bunch of math teachers to buy a lottery ticket was hard. But then I just had to put it one way. I was like, don't think of it as lottery tickets. Think of it as a-hole insurance. Meaning, if I happen to win this lottery and you don't, you're going to be so mad for the rest of your life. But here, you protect yourselves against jerks like me that would be rubbing it in for the rest of your life. So they're like, all right, I'll give you $2. Okay, and we're back on task now. It says, evaluate the iterated integral by converting to polar coordinates. So, it's got the integral from 0 to a, integral from 0 to radical a squared minus y squared, of y dx dy. Now you might be thinking, like, why would it matter if it's dy dx or dx dy? Only because it's telling us that these equations are x equals 0, right? X equals radical a squared minus y squared, y equals 0, and y equals a. So, what I want to do is graph those. So that we can come up with our rectangular region. And then we can use that to convert to polars. So, this is x equals 0. X equals positive radical a squared minus y squared. Square both sides? Exactly. And you get exactly. It is a circle with radius a, but it's actually not a circle because we only got the positive side of it. So this isn't negative here, so it's just going to be that. Can you follow that? And this right here is the point a comma 0. So far so good? Now, y goes from y equals 0, which is this line, to y equals what? Well, that works out nice. Right? Because isn't this point A right there? 0 comma A? So that means our region is right here. That's the region bounded by those 4 equations. So that's a really important step that people are not willing to take because they don't want to graph it. Otherwise, I don't think you could come up with the fact that now we know that our R is going from what? From 0 to A. And our theta from 0 to pi over 2. And now I can write it as R dr d theta. Okay? That's probably going to confuse you because you just got here and didn't watch the video, so the video will help you with that. Okay?
Why is A always 0? Isn't A always A? It just, the angle moves? I mean, in that...
Okay, so now we've got to convert our y into what? R sine theta. Okay, now, when you don't have radicals, it's in your best interest to just square that out. So 0 to pi over 2, 0 to a of r squared sine theta dr d theta. Let me just look at something that I did earlier today. In this one, this is number 11, okay? If you want to see number 11, you could pause it and look at it. But notice that in this one, this was our function. It was already given it to us in polars. We were just practicing figuring it out. We left the r out of this because then we let u equal 9 minus r squared. Du then is negative 2r dr, and that r becomes very helpful in terms of u substitution. So that's just a hint. All right, back to problem number 15. We're integrating this with respect to r first, so it's 0 to 2 pi of r cubed sine theta over 3. Thank you, Mish. Pi over 2 of r cubed sine theta over 3 as r goes from 0 to a d theta. Okay? So that's going to be a cubed over 3 is a constant. Do you agree with that? So I'm just going to take that out of the integral. Okay, I'm going to pause it while you guys look at this. Okay, so I've factored out this a cubed over 3 because it's well, I haven't factored it out necessarily. I just brought it out of my integral because it stops me from making a mistake here, confusing which variable we were integrating with respect to. Okay, so that gives me a cubed over 3 times, the integral of sine is negative cosine times negative cosine of theta as theta goes from 0 to pi over 2. So that's going to be a cubed over 3 times. All right, cosine of pi over 2 is 0 minus cosine. Is that a 0 at the bottom there that I just wrote like an A? Cosine of 0 is 1, but it's negative. So you're going to get a oh, hold on. No, it's just minus positive 1. Thank you. So it's going to be a minus a cubed over 3.
No. Cosine of 0 is 1.
Oh, here. This is where I messed this up. Here. This is just this, and that was like that, right? All right. So it's times positive 1. So it's a cubed over 3. So what we've learned is that the volume, you want me to try to draw it? Seems a little risky. Feel free to turn the video off at this point if you wish. We're going from, yeah, I think I could draw this. Right? That's our only region. It's y. So once again, it's that same picture. It's like that, right? The volume of that thing is a cubed over 3, depending on what a is. That's what our shape looks like. Boom!